Okay, we're going to go over the review packet. So you're told the probability of A is 0.3. You're told the union is 0.6, and you're told the intersection is 0.2. So I'm going to use that intersection information first, because if the intersection is 0.1, then I'm going to write 0.1 right here. Okay, let's use a color that's better. 0.1. So n is 0.1, 0.1. Okay, so next, we know that A is 0.3, so that means this entire circle is 0.3, so this has to be 0.2, because both of these have to add up to 0.3. Okay, now we know that all three of these have to add up to 0.6. So if this is 0.2 and 0.1, this has to be 0.3 so that they can all add up to 0.6. So P is going to be 0.3. Okay, now let's find Q. The whole box has to add up to 100%. So if this pinkish area is 0.6, Q has to be 0.4, because 100% minus 60% is going to give me 40%, or 0.4. Okay. Now this question here says find the probability of B prime. So this means not in B. So from our picture here, we know that the probability of B is equal to 0.1 plus 0.3. The probability of B is 0.4. Therefore, the probability of B prime is equal to 0.6. Why? Because 1 minus 0.4 equals 0.6. Okay? So that is the answer for part B. Okay, now let's do question 2. The question is write down the value of P. So if we know that this here is 1/5, this here is going to have to be 4/5, because these branches of the tree must add up to 1. You're either going towards A or you're not going towards A. So the value of P equals 4/5. Okay, so what is the probability of B? So what we're going to do is find the probability of A and B plus the probability of A prime and B. So this pathway and this pathway. So we're going to have 1/5 times 1/4 plus 4/5 times 3/8. And then that's going to give us 1/20 plus 12/40. Well, 12. Let's get a common denominator. So we have this is 1/20 plus 6/20, which is going to give me 7/20. Okay, you might want to hit pause to think about that. So that's this yellow pathway and this yellow pathway to get us the two pathways that add up to probability of B. Okay, now we're going to find the probability of A prime given B. So we could take out our formula packet and think of it this way. A given B is the intersection of the two things that we have here divided by the probability of what's given. So this is saying find the probability of the intersection of A prime and B divided by the probability of what's given, which is B. You might want to hit pause and think about that. Okay, so A prime intersection B, A prime intersection B is this route right here. Okay, so this route in the numerator is 4/5 times 3/8. Okay, my denominator is the probability of B, which we just found here, which is 7/20. Okay, let's simplify this blue numerator. 4 times 3 is 12. 5 times 8 is 40 over 7/20. Okay, so a fraction divided by a fraction, we could get the reciprocal of the denominator fraction and turn this into multiplication, and we have 12/40 times 20/7. So fraction divided by a fraction, we take the reciprocal of the second fraction and we can change the division to multiplication. Okay, so now I've got 12 times 20 divided by 40/7, and let's simplify this a little bit. 20 goes into 40 twice, so now I've got 12 over 2 times 7, which is 14. Okay, that could be simplified even further, which is 6/7. I will accept answers that are not simplified. That is completely fine. Okay, question 3. Okay, the eye color of 97 students is recorded on the chart below. A student is selected at random. Write the probability that a student is male. Okay, so the first thing we need to do is we need to add up all the males. 21 plus 16 plus 9 is going to give me 46 males. And we need the total of all the students, which is 97. So this is going to be equal to 46 divided by 97, because the total number of males is 97. Oh, sorry, the total number of students is 97, and the total number of males is equal to 46. Okay. Question B. Write down the probability that the student's eye colors are green, given that the student is a female. Okay, so my denominator has to be the total of females. So 19 plus 19 plus 13 gives me 51. So my denominator is 51. Now, how many females have green eyes? And that's 13. That's a lot. Okay, so my numerator is going to be 13. So there's 13 females with green eyes, and the denominator is all the females because of the given females that we're working with. Okay, find the probability that a student has green eyes or is male. So so my numerator is going to be 21 plus 16 plus 9, because those are all the males. My denominator is going to be, green eyes or male. So we also have the female green eye people, which is 13. And then my denominator is the total number of students. So these are the number of males, and these are the females that have green eyes. So, and this is 59/97. So just remember, the words or means union. Okay, Whenever you see or, that means union. All right. Next page. Okay. In a class of 100 students, 55 play football, 75 play rugby. Each boy must play at least one sport. Okay, find out the number of boys who play each sport. So the first thing I did was I made a little Venn diagram. I'll do that on the side over here. Okay, and I'm going to call that A, B, and C. This is the football circle. This is the rugby circle. Okay, each boy must play at least one sport. So we know out here that's going to be 0. So A plus B plus C has to add up to 100 because there's 100 people there. Okay. 55 play football, so I can say A plus B equals 55. 75 play rugby, so B plus C equals 75. So now I can do some substitution because A plus B is 55, isn't it? So I'm going to rewrite this equation here, and except I'm going to substitute A plus B with 55. So I have 55 plus C equals 100. Subtract 55 on both sides. C equals 45. Okay, let's write that in here, 45. Okay, next, now that I know C, I can substitute this value on the second equation with 45. So let's use that second equation. We have B plus 45 equals 75. And now I subtract 45 on both sides, and I get B equals 30. Okay, and then we can find A. We know that A plus B equals 55, right, from this equation right there. So I'm going to replace B with 30. And so now I get A plus 30 equals 55. So A equals 25. Okay, so now we have information here. Write down the number of boys who play only rugby. Only rugby is going to be Write down the only rugby is going to be 45. I didn't answer I here. Find the number of boys who play both sports, and we know that there's 30 that play both sports. Question A, this is 25. Okay. All right. One boy is selected at random. Find the probability that he plays only one sport. Only one sport. That is going to be 25 plus 45 divided by 100. Okay. So that's going to give me 70 over 100, or 70%. Now, careful note. This here says the number of people, and this says probability. Whenever you're doing probability, it's going to be value less than 1. Right? Because it's a fraction or proportion, right? whenever you're doing numbers of things, this is counting. Okay, we're counting the number of people here. Okay, given that a boy is selected at random, plays only one sport, find the probability that he plays rugby. Okay, so one sport playing people is 70, right? 25 plus 45. Let's write this down. 25 plus 45. Those are the one sport playing people, and the probability that they only play rugby is 45. So we have the intersection of rugby and one sport divided by one sport people. And we simplify that, and we get 45 over 70. You can simplify the fraction if you wish. Okay. Question A. Let A be the event that the boy plays football and B the event the boy plays rugby. Explain why A and B is not mutually exclusive. Okay, mutually exclusive is when the circles do not overlap, right? So when it's mutually exclusive, you know that the probability of A union B equals probability of A plus probability of B, right? And we know that also there's another way to think about it. Probability of A is 0.55, and the probability of B is 0.75, and the union is, what is the union? Well, we already know that this is greater than than 1, right? So this can't work. Right. Another way to think of it is the intersection, if it's mutually exclusive, has to be 0 for the probability. And we know that the intersection is 0.3. So 0.3 is not equal to 0. Therefore, it can't be mutually exclusive. Okay, next question. Show that they are not independent. Okay, so for independent, the formula for independent is the probability, the intersection of A and B must equal the probability of A times the probability of B. Now, the probability of A is 0.55. The probability of B is 0.75. And that's going to give us 0.4125 if you use a calculator. And we already know that A intersection B, we already know is 0.3. So since 0.3 is not equal to 0.4125, we know it is not independent. Okay. All right. Let's do number 5 now. Okay, so x is the sum of the dice. So I added the sum of the different dice here. Okay, 1 plus 1 is 2. 6 plus 6 gives me 12. Find the probability that x equals 6. Okay, so what I did here is I'm going to highlight all the ones where x equals 6. Okay, so my probability is going to be, let's see, 1, 2, 3, 4, 5. There's 5 yellow things, so it's 5 over 36. Okay. What's the probability that it's greater than 6? So I'm going to add all these blue ones together. Okay, if I add all those blue ones together, we know that that's equal to 21 over 36. Okay. Last one here. What's the probability that it equals 7 given that it's greater than 5? So greater than 5 is anything that's yellow and blue. So the denominator is going to be the 5 plus the 21, right? Because the yellow ones and the blue ones are all greater than 5. So given that it's greater than 5, the probability that it equals 7. So I'm putting triangles around all the ones that equal 7. How many triangles are there? 1, 2, 3, 4, 5, 6. Okay, so there's 6 triangles. And so we end up with 6 over 26, which is a fine answer. And if you simplified it, you would have 3 over 13. Both answers are just fine. Okay, last question on this page. Elena plays a game where she tosses 2 dice. If the sum is 6, she wins 3. If the sum is greater than 6, she wins 1 point. If the sum is less than 6, she loses k points. So we're going to try to find the expected value, and if the points is 0, so we know this is a fair game. If there is no expected win. So if the sum is 6, so we have 5 out of 36 chance that the sum is going to be 6. And we're going to win 3 points. Greater than 6 is the blue ones here. We have a 21 out of 36 chance that it's going to be greater than 6, and we're going to win 1 point. So I'm going to put 1 point here. And then she's going to lose k points if it's less than 6. So all of these non-highlighted ones are less than 6, and there's 10 of them. Okay, and this, the expected value is going to be 0. So now we can solve for k. So we simplify this, we get 15 over 36 plus 21 over 36 minus 10k over 36 equals 0. All right, so since the denominator is 36, I could multiply both sides by 36, and then my equation now becomes 15 plus 21 minus 10k equals, well, 0 times 36 is 0. Okay, so 15 and 21 is 36 minus 10k equals 0. So let's subtract 10k on both sides. I have 10k equals 36. Divide both sides by 10. We know that k equals 3.6. So we know that k needs to be 3.6.